Good morning, everybody. Welcome to week 29. I'm going to quickly go over what we're going to be doing this week. So the first thing you'll see is I do have the answer. Well, it's not the first thing you see, but you will see that I have the answer key to last week's assignment up on Schoology for you. At this point, it should be turned in. You should have something turned in. I'm not going to be too harsh when grading it because it was our first time doing any sort of beam analysis, but you can check out your answers to the answer key, see where you were successful, see where you may have struggled, and so forth. This week, you're going to have another beam formula PowerPoint. We're going to be going over some shortcuts to make the analysis a little bit simpler. So I'm going to have you first take notes on this, and then you'll be doing a worksheet along with it. And so check out the PowerPoint, take notes where you want, and then obviously you can have the PowerPoint open while working through the assignment. But this PowerPoint just goes over different ways to calculate our beam analysis. So totally forgot where my brain was going there. Anyway, so beam formulas, similar loading conditions equal similar shear and moment diagrams, span length of beam, magnitude of applied load, location of applied load. Here you go. You've got your shear and moment diagrams. Uniformly distributed, so two different types. You can see that their load is similar, but obviously not the same, but their diagrams all look similar. So both of these beams are simply supported and the loads are uniformly distributed. Notice the shape of the shear diagrams are the same for the two beams. All right, so here is the reaction force formula. So this is the simpler way of calculating those beams, our beam analysis. So instead of FYA, they have just A. Instead of FYB, they just have B. They just give you W and L, and they use it as such. So here, you can calculate this. So in our last worksheet, we did sigma MA equals 0. This one, they're doing sigma MB equals 0. So you can see RA instead of FYA, RB instead of FYB, and then they use that equation to simplify the process. So go through that, check it out. Then you've got that worksheet down here. This one. Again, you're just going to be doing what you did last week. Use the beam formulas to complete the activity. I'd like you to use the shortcuts this time. You can either hand draw your shear and moment diagrams, or you can use MD solids at school and can copy and paste them in. It is a free download for home. So if you want to, you can download this at home and it won't cost you anything. And I'm going to quickly show you what MD solids look like. So let me see if I can get it. There it is. So let me share the screen with this. It's interesting. It did not open the way I expected. There we go. When you click MD Solids, it's going to look like this. So if you have access at school, obviously you can click on it. It's going to be on your computer. It's going to say MD Solids 4.0. Again, download it at home. It's free. You're going to use the determinant beams, and this is just you going through. So clicking the first beam is what I always do. Put in the beam length. So for this one, we know that they give us the information is 16 feet. So right now it's in inches, so I need to change that. We don't have a left support, but we do have a right support, and it is the full distance across. So enter. It's going to open this up for us. So this is where it's starting to look like your beam diagram. But there's still some more information we need to put in, like where our load is, our concentrated load. So I'm going to go grab a concentrated load. You can see by me clicking on it, it says concentrated load. And I can put in the load location. I know it's halfway, so 8 feet. And our load magnitude for a concentrated load, it's 500 pounds. So there we go. I've got my beam diagrams. I've got my shear and moment diagram. You will still need to draw your free body because we don't have that on there yet, but it gives you your shear moments. You can use a snipping tool, take a picture. Computer's freaking out a little bit. Let's see if we can. For those that don't know it exists, you'll just see more of that. If you type snip into your computer, it'll bring up the snipping tool, and then you can take snippets of each diagram. My computer's taking a little bit, so let me see. It comes back to life so I can show you. It's not going to, that's fine. Anyway, so snipping tool, take those diagrams, put them in. You're still going to need to do your free body and show your calculations using this week's formulas. But that's how you use MD Solids. Pretty straightforward, pretty easy. But if you have questions, obviously feel free to ask me, and I'll see you guys later.